In this lesson, we'll look at Exhibits C and D, the categories of evidence for species change. Exhibit C will be comparative anatomy. Charles Darwin is going to look at the anatomical structures of different species to try to find patterns and to see similarities and to try to explain those similarities. For example, in this slide, we see the limbs of a diverse array of species. Here we have the fin of a whale, the wing of a bat, the arm of a gorilla, the leg of a tortoise, the front limb of a T-Rex, and the wing of a bird. Now, anatomists at the time, in studying these limbs, identified a common bone structure to the limb. There was one bone connected to the shoulder, followed by two bones, and then a bunch of little bones and digits. And we're going to call this the one bone, two bone, digits common structure. So that's a pattern. All of these limbs share this bone structure. Now, why would all the limbs of very diverse organisms share this structure? So that's what we have to sort of explain. These limbs have diverse functions, but they have a shared structure. Why would that be? Well, at the time, the prevailing view among Christian thinkers and most naturalists at the time was the special creation hypothesis that this is somehow an indication of God's handiwork. And so perhaps God had a design for a general limb in God's mind, and when God was making limbs of different species, then just sort of tweaked the limb so to kind of generate differences that would be adaptive for their particular lifestyle, but still shared the underlying bone structure, the one bone, two bone digits pattern. So the special creation hypothesis had an explanation that this revealed sort of God's design plan. Darwin, of course, is going to depart from that explanation and suggest a radically different idea, that this common bone structure, one bone, two bone digits, is a trait inherited from a common ancestor of all these different species. And so the idea is the common pattern reveals a feature of a long extinct common ancestor. All of these species today have inherited this common feature from that ancestor long ago, but in the intervening time, these limbs were crafted by forces in nature to perform different functions. Now, Darwin's going to use evolutionary trees to illustrate this idea of common ancestry. Evolutionary trees show the relationships of current species to each other. Species share common ancestors at different times in the past. So the way the tree works is you put the current species at the top of the diagram, and then you have these lines that converge as you go down the diagram, and this is going back in time. So here we see at the bottom of the diagram the common ancestor. So this would be a species living in the past that would have been the common ancestor of all three living species today. Now, if we consider the characteristics of the three species, we will notice that the leopard and the domestic cat here are more similar than either of these two are to the wolf. So the wolf and leopard are less similar than the leopard and the domestic cat. Now, Darwin has an explanation for why the leopard and the cat are more similar than the leopard and the wolf. He'll argue that these two species have many shared traits because they inherited them from a recent common ancestor. Notice then, this common ancestor is sometime in the past, but not as far back as the common ancestor of all three species. And so the recency of the common ancestor means there hasn't been much time for any differences to emerge in these two separated species. By contrast, the wolf and the leopard had a more distant common ancestor, which means there's more time for new changes to emerge in the two species, and so fewer shared traits. Now, let's use evolutionary trees to see how Darwin's going to explain the common bone structure in these diverse limbs of vertebrates. Here we see an evolutionary tree showing the evolution of vertebrates from a common ancestor down here. Here we have fish, so these would have been the first kind of swimming vertebrates in the ancient oceans. And then we're going to have the evolution of legs in amphibians. So the first tetrapods would have been amphibians. And notice all of these vertebrates up here are tetrapods. The reptiles, the birds, and the mammals have 4 limbs. So these legs emerged at this point in the history of vertebrate history. And the idea then is the reason all of these vertebrates today have 4 limbs is because the common ancestor of those land-living vertebrates had 4 limbs. So the one bone, two bone digits pattern was found in the common ancestor and inherited by all of the current tetrapod species. So tetrapods inherited the one bone, two bone digits pattern from a common ancestor amphibian, but the limbs changed over time as species adapted to new lifestyles. And Darwin had a kind of term for this. He called it descent with modification. So the common bone structure was inherited, but it was modified by forces in nature. In the evolution of whales, the limb was modified to become a fin. In bats and birds, the limb was modified for flight. And in other kinds of species, modified for locomotion, or the T-Rex with the claws for a certain kind of activity in tearing up prey, for example. So Darwin is going to reject the idea that the common bone structure found in the limbs of vertebrates is due to God's sort of general limb plan. Rather, Darwin's going to say the common bone structure is the result of descent with modification. The common ancestor had this bone structure and passed this structure along to its descendants. Now it's time to move on to Exhibit D. We can think of this as the ability to classify species using some kind of system like the kingdom, phylum, class, order, family, genus, species system, or we can think of it as groupishness, that species out there in nature have the capacity to be grouped based on similarities. Now Darwin's going to argue that this groupishness is evidence of species change. We've already seen how an evolutionary tree captures the relationships between current species and common ancestors. And we said that Darwin's going to say that the leopard and the cat share lots of characteristics because they had a recent common ancestor. There hasn't been much time for change. Whereas the leopard and cat show fewer similarities with the wolf because they had a more distant common ancestor. So there's more time for change. So again, then, the idea that species can be grouped is explained by this idea of an evolutionary history from a common ancestor. We can group the cats together because they had a recent common ancestor. So groupishness is what you would expect if species were evolving from common ancestors. So at the top of this diagram, then, we have that kind of classification system, the kingdom, phylum, class, order, family, genus, species. Now, not all of them are represented here, but we can think of them as sort of groups within groups. The kingdom, let's take the animal kingdom, has all of the different animal species in it. And then as we go to these other smaller groupings, we go down to the class and the order and the genus, for example. And here we have some representative examples. In the animal kingdom, here are some examples, and in the subphylum, the vertebrates, and the class mammal, and the order carnivore, and the genus canis. And so then we get to dog. So dog is one animal among many. It's a vertebrate, it's a mammal, it's a carnivore, and it's in the genus canis with wolves. Now Darwin's going to argue the reason we have this kind of order, we can have these classification groupings, is because of the evolutionary process from common ancestors. So this process of common ancestors diverging into multiple species over time is what explains the groupishness of species on Earth. So Darwin's, again, using groupishness as evidence of species change as captured in evolutionary trees. So we've now looked at Exhibit A, B, C, and D. Exhibit A was fossils, Exhibit B, the geographic distribution of species, Exhibit C, comparative anatomy and vestigial structures, and Exhibit D, the groupishness of species. All of these categories of observations and evidence Darwin amassed in his famous book On the Origin of Species by Means of Natural Selection, and he's really making a case, one long argument against the special creation hypothesis. So all these categories of evidence in Darwin's mind were evidence that species are not fixed. They can change. Now in the book, he doesn't just sort of make the argument that species have changed. He goes on then to offer a mechanism of that change, how species change in nature and how new species can arise. And that process he called natural selection. We'll take a look at that process in another lesson.